Hi, my name is Heather, and I'm going to be doing the Chapter 3, Problem 81. And the problem says that 3 balls are launched simultaneously. The red ball is launched at an initial velocity directed at an angle above the horizontal. The blue ball is launched vertically with a speed of 11 meters per second, and the yellow ball is launched horizontally with a speed of 4.2 meters per second. The blue and the red balls reach the identical maximum heights and return to the ground at the same time. And then the red ball returns to the ground to meet the yellow ball in the same place along the horizontal. So you have to find the launch speed and the launch angle for the red ball. And to do that, you need to find the x and y components of the vector. Now, since the red ball and the blue ball reach identical maximum heights, the y components are the same. And the blue ball only has a y component because it's only going in the y direction. So that would indicate that the red ball's y component is equivalent to the given speed for the blue ball. And this is the same for the yellow ball, except on the horizontal. So the yellow ball only has an x component because it's only going in the x direction. So that would mean that the red ball has the same x component as the yellow ball. And so with the x and y components, it creates a right triangle with the initial velocity of the red ball being the hypotenuse. And this is the picture here. So this is the y component and the x component. And that's the red ball vector with the angle. And so you can move this y component over here to make a perfect right triangle. And from that, you can use Pythagorean's theorem to find the length of this vector. So it'd be the square root of v naught x squared plus v naught y squared. And so that would be the square root of 4.2 meters per second squared plus 11 meters per second squared, which would get 11.8 meters per second. And that would be the launch speed. And for the launch angle, as you can see with this right triangle, we're given an opposite and an adjacent. So with that, you can actually use the inverse tangent function to find the angle. So you would divide the opposite by the adjacent. So it'd be the y component divided by the x component. And that would be the inverse tangent of 11 meters per second divided by 4.2 meters per second, which would be 69.1 degrees. And that would be the launch angle.